You hate this class. Really? This class is so fun.
You know what would make it more fun?
What's that?
You know those onion articles like last year? It's like one of those.
You want a good article? Go to bustedcoverage.com.
Bustedcoverage.com.
Just look up Packer fan gets revenge on cheating ex-boyfriend.
Oh, I saw that.
Oh, I saw that.
Is it classroom appropriate?
Yes.
Well, the guy isn't in this class, so go ahead.
Here, I'll do it from my cell phone.
I've seen it and it's classroom appropriate.
Bustedcoverage.com.
Yep.
It just sounds sexual.
How far do I got to scroll down to get to the Packers one?
Is it on their own page or is it?
Should I get this year next to it?
I'm already
I
happy.
just Googled Packer fan gets revenge on cheating ex-boyfriend. It's like second result.
All right, here it is. Let's see. Meet Tati March. She's the Packers fan who was holding the my ex cheating boyfriend is watching from his dorm instead at Sunday's game against the Eagles. We tweeted out the photo this morning. A couple Green Bay media outlets took notice, and now she's getting some run. There has been a short investigation into the backstory to the sign, and we can report that the guy in the camo is her current boyfriend, Zach, who plays football at Concordia. Plays the guy in the beaver pelt.
Yeah.
Okay. Let's see. From what we can tell, Tati was getting revenge on her boyfriend before Zach came into her life. That's right. She's still thinking about destroying the ex while enjoying a Packers game with her new boyfriend. I don't need Dr. Phil to tell me that's not a good sign for Zach.
Is that the girl that was holding up that sign?
Yeah.
Yes.
Dating someone?
They both go.
Oh, they both go here?
Yeah.
So is the cheating boyfriend somebody who goes here too?
I don't have no clue.
It's you, isn't it?
He's
He's like,
the three people. His name is.
I have no clue.
I just was told about the article and saw it.
I see.
It was Facebook like 50 times.
I see.
That's really fun.
Who's the girl?
It is.
I'm the cheating boyfriend.
Yeah, that's a bookmark.
See, if we just get in like one of those at the beginning of class, it just makes the class go by.
Well, and I'm okay with that, but the problem is finding classroom appropriate material. I'm okay if it's borderline.
We're all adults here.
Okay. Yeah, but A, we're recording it, and B, it's a Christian university, so I have to make some sort of level of an attempt to bring a Christian worldview into the classroom.
Do it before the recording.
Still. I mean, I'm all about good humor and stuff like that, but in terms of what officially is delivered in the classroom, borderline is acceptable. Borderline is acceptable, but when you cross the border,
All right.
then
I'll look up an article each night. And
Okay.
That's appropriate.
that's fine.
All right.
That's fine. I'm good with that. Now, it can really skirt the border, is what I'm saying. It could be right there, but
All right.
maybe the litmus test is you need to be able to tell it to your pastor without him immediately condemning you. He can look very uncomfortable.
There are a lot of pastors that have good sense of humor.
Exactly, that's what I'm saying.
Like Dr. Firetalk, he'd laugh at pretty much anything.
Yeah, sure.
That's true.
Yeah, like I told my pastor my garage door code, which is not classroom appropriate. I texted it to him actually, so He is memorabilia, textual memorabilia, whatever. All right, so for your homework, we were to update our MergeSort to work on strings, correct? So let's start off by filling an array with some strings. Let's see, can we be interesting with this? We could go through, yeah, let's just do this. So we're going to create a string array. AR, and this is going to be cat, dog, apple, ape, apple, goat, elephant, zebra. Good enough. Okay, so we have a string array now filled up with some strings that are not in alphabetical order. Now we need to update our display array to be able to display string arrays. So this guy will take in a string array, and that's it. So now display array is done. Okay, we didn't have to change anything else. An array is an array. We just had to make it work for a new kind of array. Now we need to update MergeSort. So MergeSort also is going to take in a string array instead of an integer array, as is MergeSort helper. So we need to make MergeSort helper take in a string array instead of an integer array. Now begin and end, all these things stay the same. All of those stay the same. No change. Okay, so just as a starting point here, let's make sure that our display array is working. So this should show.
There's gonna be errors because of the string. Yeah, attempt not being.
Oh, okay. Well, we're not going to do that then. Yeah, I got it. So here, we'll just finish writing it. All right, so in MergeSort helper, taking a string array, begin and end stay the same. So all this crap up here stays the same, stays the same, stays the same. Our temp array is no longer an integer array, it's now a string array, because we're going to temporarily store a bunch of strings instead of a bunch of ints. And it's going to be a new string array of size length. Okay. As we spin through, we're going to place the right thing in temp. Now, this is the secret line of code we had to fix. Before, we were comparing one integer to another integer. So if this guy came before this guy, we would do the swap. So what we want to do is we want to say if this guy, this guy's a string. Now I did introduce the compare to method, right?
Yeah.
Okay. So that guy dot compare to, but you could have also used the method we wrote for our string sort for bubble sort. So if that guy less than 0, so if this string dot compare to this string returns a value less than 0, which means that this guy should come before this guy alphabetically.
Would it be less than or equal to?
Well, not in the way we originally wrote this. Yeah, equal to 0 means they're the same. It wouldn't hurt anything because our else handles they're the same or it's greater than. Yeah, so just mimicking what we had before, yeah, it wouldn't break it. All it would mean is where the ties happen, how ties are dealt with. So less than 0, because compare to returns a 0 if they're the same string. Something less than 0 if the calling string should come before the string you passed it. Something greater than 0 if the calling string should come after the string you passed it. So the rest of this should work. The rest of this should work. That should be it. And there's our original. And there's our sorted. Make sense? Okay, so besides updating a bunch of things to string arrays from integer arrays, all you had to do was change this one line.
You can make it reverse alphabetical order real easy too. Just like that.
That. So now it's descending.
Show how you do it without the compare to.
Using our own method. Okay.
You just put it back in there for descending order. You put it as greater than
Doesn't matter. Okay, so rather than using the built-in compare to, you want to write our own compare to, which we did write previously, right? So did you use the previous one we wrote? Okay, so let's go back and grab that one here.
Forgot about compare to.
Which is fine. We wrote one. So here's our method compare strings. So we'll just grab that method. So this guy returns a, let's see. He returns a -1 if A should come before B, a 1 otherwise. Correct? 0 if they're identical, which is fine. So -1 if they are the if this string, the string that we passed first, should come before the string that we passed second. So now we'll go back into this guy. We'll throw in our version of compare strings. So then down here, instead of compare to here, we'll say driver dot compare strings. The first string we're going to pass it is this guy. Second guy we're going to pass it is this guy. And if that gives us a value less than 0, we should have our sort. So that's the line for compare strings. How did you write the comparison? Where did you go south?
I didn't even know that I was supposed to do that. I couldn't figure out how to do an input for just string A and string B if I had multiple.
Okay, so you were thinking about the array as being too big.
Yeah.
You were thinking like, okay, I have 30 things I need to compare.
And I was thinking, how would I compare all 30 of them when I can only put in 2?
Right.
So,
Yeah, you're only comparing the one we're looking at and the other one we're looking at, just those two.
Yeah, and then just it was really confusing thinking about the position and where it was begin left and begin right with how compare strings works and how it compares. It just it didn't make sense to me, so I wasn't able to.
Well, does it make sense now? Or still not?
It's still not.
Okay, well, so
Just, like go through how compare string gets the input from
well,
begin left and begin
forget about how compare string gets the input. Just look at what compare strings does. Compare strings takes in 2 strings, exactly 2 strings. This is what this dude does. This is a tool we bought at Home Depot. We pass it 2 strings and it does something. So it's going to loop through all the elements of, we chose to start with the first string. If we've run out of characters in our second string, then we're just going to return 1. Else if the character in A should come before the character B, the reason we can say I is greater than b.length here is because we know this loop is looping on the length of A. Okay, so if we're still kicking and I is greater than B's length, that means B is the shorter string, so we're going to say it should come first alphabetically. That's why we return the 1. That B, this guy, should come before this guy. Otherwise, if the character we're currently looking at in A should come before the character we're currently looking at in B, we'll decide that A is the string that should come first alphabetically. So we return our -1. Else if the character we're currently looking at in B should come before the character we're currently looking at in A, we'll return a 1. B should come first. Okay? So this goes through all the characters in A. And if at some point in here any of these are true, this method's over. If we're still kicking after this, that means that A is likely the shorter of the two strings, or it's the same length as the other string. Therefore, if it's the same length, that means we've compared every single character of both strings. Therefore, we're going to return a 0. They're the same. Otherwise, we'll return a -1. A must be the shorter of the two. So, because it's shorter, it comes first alphabetically. Okay, so that makes sense what compare strings does? So now we can just trust that compare strings works. Trust that compare strings works. We know we pass it two strings, it'll return a -1 if the first string should come before the second. It'll return a 0 if they're the same string, and it'll return a +1 if the second string should come before the first string. Okay? So now we're back down to our merge sort, specifically the merge step. Now, so what you're telling me is you had a misunderstanding of the merge step, so it had nothing to do with strings. You were struggling with it even when it was ints. Okay, got it. So let's look at MergeSort helper. So you started running into problems up here, like how we got all these values?
Well, I mean, I understand where we got those values from, but just using the string and the position of each like word, I didn't get how that made sense, or how it was able to go through each one and compare all of the different words with each other when it could only take in 2. I get how you compare 1 and 2, but I don't get how you can compare those two with the rest of the string.
Okay, got it. So it's really the MergeSort algorithm that you struggled with. So let's go back here. So do you want me to do this with strings, or are you okay with ints?
Do it with strings.
Okay.
I'm fine with ints.
Huh?
I'm fine with ints.
You are fine with ints. Okay, so I don't have to do it with strings. Okay. So let's steal this real quick. And let's jumble these. 5, 3. Actually, what I'm going to do, just so we can see our last merge step. Okay, so let's leave it at this. So we've already gone through our algorithm. We've called MergeSort on the first half. We called MergeSort on the second half. It went all the way down, did all the sorting, blah, blah, blah. We're finally back up to our original call. We finished MergeSort on the left. We have completely finished MergeSort on the right. So notice that the left half of the list, in and of itself, is sorted, right? So 1, 3, 7, 9, 14. That is in order. The right half of the list is also sorted, okay? So are you good with that? To that point? Okay, so now we have two lists. So if I kind of move them over here. And we have begin left, begin right, end left, end right. Now remember, the very first thing we did in code is we set up begin left, begin right, end right. Okay? Then we made our two calls to merge sort. Where we're at right now is we're right here. Two calls are back. Now we need to merge the two halves. The two halves are currently sorted in and of themselves. So our values here would be begin left points to the very beginning of the left half. Begin right points to the very beginning of the right half. End left points to the last legal bucket in the left half. End right points to the last legal bucket in the right half. Make sense? So far, so good? So this is what those variables all point to after we've done this math. So begin left is begin. End left is begin plus the length divided by 2 minus 1. So that will make it point here. Begin right points here. End right points here. All the math makes it point to the right places. All right. Now, very first thing we do to merge the halves, we create a temp array that's the same length as the original array. And currently it's going to be blank. There's nothing in there. All right, and just so we don't confuse memory addresses, I'll just take the memory address portion of this off. Okay, so this is bucket 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 of this guy. And we might not visualize this one as being split, so really that's a single temp array there. Okay, the only reason I showed this one as being split is so we can visualize it as a left and a right. Good with that? All right, so now the merge step says we're going to go through temp.length number of times. Notice that temp's length in this case is 10, which is the exact same length as the entire thing here. Number of values we have to place. Those are both the same number. Okay? So we're going to place temp.length number of values. Very first thing we ask is if begin left is greater than end left. That means that from all our placement up to this point, begin left has moved to the point where it's now longer. It's past the end of the left half of the list. So this guy is now, we've already placed all these values. Okay? So we ask that. If that's the case, if begin left is beyond end left, then the rest of our winners are going to come from the right half of the list. Okay? So begin left is less than end left. Winner is begin right. We increment begin right. Else if begin right is greater than end right, all our winners will come from the left half. Make sense? And then increment begin left. In this case, they're both in legal positions. Begin left, begin right, both point to the beginning of our array. Okay, and these are the two variables that are going to change as we go. Very first question we ask is, should the string at position begin left come before the string at position begin right? In our example here, should the int at position begin left, so if you want me to rewrite this part real quick, this says AR at bucket begin left less than AR at bucket begin right. It's not going to compile right now because we did change this over to strings, but that's the question we're asking. Should this integer come before this integer? If it should a 1 come before a 1? Is 1 less than 1? That is AR at bucket begin left less than AR at bucket begin right? 1 is not less than 1. So This will be false. We'll fall into the else, and the else says set temp at bucket I equal to begin right, then increment begin right. So we're going to set temp at bucket 0, because remember I goes through 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, equal to begin right, this value. So we'll put a 1 in here, then increment begin right. Spin back up, ask the question, is begin left a legal position? Yes. Is begin right a legal position? Yes. Should the value at begin left come before the value at begin right? Yes. Put in the 1, increment begin left. So we just got into this if statement. The value at begin left comes before the value at begin right.
So in the compare to method that we have, we would be comparing like the -1 to 0 to 1 depending on if it's...
Well, this would be the string at begin left. This would be the string at begin right. We pass it into compare strings. Compare strings, this method returns for us an integer. It'll return for us the integer -1 if this guy should come before this guy alphabetically. It'll return for us a value of 0 if these guys are the same string. And it'll return for us a value of 1 if this guy should come before this guy alphabetically. So we're asking, is it less than 0? You could also ask, is it equal to -1 for our compare strings? Since we know which is less than 0, right? But we know our compare strings that we wrote always returns a -1 if this first guy should come before the second guy. So this is asking the exact same question. Does this string come before this string? That's what this Boolean expression here asks. Okay? So we place the 1 and the 1. Now, begin left is legal? Yes. Begin right is legal? Yes. Should begin left come before begin right? Should a 3 come before a 4? Yes. We'll place the 3. Follow it. Spin back up. Is begin left legal? Yes. Is begin right legal? Yes. Should a 7 come before a 4? No. Place the 4. Follow it. Is begin left legal? Is begin right legal? Yes. Should a 7 come before a 5? Nope. Place the 5. Is begin left legal? Is begin right legal? Yes. Should a 7 come before a 5? Nope. Increment. Is begin left legal? Yes. Is begin right legal? Yes. It's just barely legal, but it's legal. Okay? Because it's not greater than end right. It happens to be equal to end right. So which should come first, a 7 or a 9? The 7. Then we follow it. Is begin left legal? Yes. Is begin right legal? Yes. Should a 9 come before a 9? No. So the winner will be over here. So we'll take this guy, then we'll increment this guy. Is begin left legal? Yes. Is begin right legal? No. Winner by default is begin left. So we'll take the 9, increment. Is begin left legal? Yes. Is begin right legal? Still no. So winner by default is our 14. Increment. Now, we won't loop through again because now we have filled all of temp. So we've already placed, in this case, 10 things, so our for loop will naturally end. Okay, because I is no longer less than temp.length. So there we have temp is in the correct order. Final thing to do then is copy the contents of temp back into AR, overwriting the contents of AR. So we'll go from I is 0 to less than temp.length. Each time through, we'll do begin plus, so begin, not begin left, but begin of the entire array, all the way So each time we'll say begin plus I. So in this case, begin is 0. And we're going to go through every bucket of I. So we're going to take 0 plus 0 is this guy. Bucket 1 will be 0 plus 1. We'll put the 1. Bucket 2 will be 0 plus 2, which is there, there. So now our array in its original location is sorted. And that's the very last thing we do. So we hit the end of MergeSort helper, and we only looked at the very original call, so all the other calls had already happened. So by the time we return from this guy right here, our list is currently in this state. The state where it's completely sorted. Okay, but notice that every single time through, we were comparing one value from begin left to one value at position begin right. We weren't comparing them all at once. One value from each side, deciding which of these is the current winner. That's the merge step. Okay, does that answer your question?
Yeah, that makes sense.
Okay. All right, anything else? Okay, so now that we've covered a whole bunch of easy stuff, let's start getting into some hard parts of computer programming, right? All right. Now, did we do anything with fractions in here?
No.
Oh, man, this is going to be a nightmare. Okay. What's up? All right, so let's go ahead. We'll just use our homework class here. So let's just dump all this garbage. Oh my gosh, look at everything we wrote. Hopefully you don't need that again.
Hope not.
All right. So, tell me, what's a fraction? Number over a number. Okay, I'm good with that.
Sure.
So fractions. Fraction is a numerator over a denominator. Right? So we're going to hold two pieces of information. Now, knowing what we know right now, do we have a structure that allows us to hold more than one similar type value? Sure. What's it called? An array. So could we represent fractions as two bucket arrays? So for the example, could we say integer array AR, well here, let's say F1 is equal to 1 comma 2. That's 1/2. We can say that's 1/2. Okay, we can say integer array F2 is equal to 1/4. We can say that's 1/4. Now we have to be able to interpret it, right? We happen to know, we've made the decision that, okay, these two bucket integer arrays, bucket 0 is the numerator, bucket 1 is the denominator. We have to remember that, okay? But we certainly can represent fractions that way. All right, well now, we're going to write a little method, and this guy's going to return an integer array called add fractions. And this guy will take in an integer array F1 and an integer array F2. And just so I don't confuse some of you who seem to be misunderstanding this concept of passing values into a method, I'm going to call this first variable cat and the second variable dog. Okay? Your names of your variables here do not have to match the name up here. Okay, this is the generic reusable chunk of code called add fractions that requires us to pass it an integer array and a second integer array. What we name those integer arrays in here only have an impact on what we should refer to them as in here. Okay, they didn't have to be named the same up here. So we'll go ahead and call this real quick, even though I know we still have an error down here. So we're going to have integer array answer is equal to, is this a class method or an instance method? Class method, how do you know? How do we call class methods? Okay, what's the name of this class? HW dot add fractions. And what's the first fraction we want to add? F1. Okay. Second fraction we want to add? F2. So it's going to take in F1, so F1 is going to get mapped to this local variable cat. F2 will get mapped to this local variable dog. So inside here, we refer to those guys as cat and dog. Okay? Ultimately, add fractions, we haven't written it yet, but hopefully it will return for us a new fraction, which is the sum of cat and dog. And we'll capture that answer here. That's why we're having this guy return an integer array, because we actually need a brand new answer. We're not changing F1 or F2. So F1 and F2 hold some fractions for us. We're going to utilize those fractions to build a new fraction that is the sum of those two. And we'll return that brand new fraction. That make sense? Okay. So now we got to go back to our, what grade did we learn about fractions? Third grade? Okay, so we all have third grade math in here?
Nope, I skipped that now.
You need to know math for this class?
Okay. Well, just easy math. Easy math. You know, because in computer science here, we dumb down the math requirement, right? That's how we keep so many students. How many of you would have stayed in computer science if you had like to take math, Calc 1 through 3, and a whole bunch of math classes? Would that have like scared you off?
Yup.
No, I had to sign up for discrete mathematics, so that was kind of scary. Yeah, I wasn't even sure what that was.
Oh, discrete was scary?
I mean, it's not now.
Here's
It's
the-
really easy.
Here's the name of the scariest math class I ever took. It's called combinatorics.
I've heard of that.
How bad is that?
It's horrible.
I was pretty good at math. I emphasize was.
Not anymore.
I've heard of how horrible.
I'm probably better than most of you at math, but some of you have had some of these classes significantly more recently than me. You
So is
know,
that why your wife does all the checkbook and everything?
no, that's what we use. Who writes checks? Nobody writes checks.
I know I got time for that.
Yeah, checkbook self-balancing when you do bill pay, right?
Occasionally I have to write a check. That's just
Yeah.
part of it.
But yeah, but my wife would be in charge of all that stuff, not because she's better at math, but because she will do that and I won't. But she is good at math as well. We both were traditional computer science majors at an engineering school, so the math requirement was pretty crazy. Basically, you, as a computer science major at University of Illinois, you were basically forced into a math minor because it wouldn't have made sense not to. You had to take like one extra class for the math minor. All the other classes were required for computer science. But it's okay. We're liberal arts school here, so we need to reduce the requirement a little bit to keep our numbers up in the sciences, and that's the way it is. But we could at the very least assume all of you had third grade math. It's a good assumption. So
memory might be.
okay, but we all know what fractions are. Let's start with that. Some of us might not know what derivatives and integrals are, but we all know what fractions are. Fair bet. You had fractions?
I was actually pretty bad at fractions,
Okay, but you had them.
but I had.
Okay, did you ever have integrals or derivatives?
What's that?
Yeah, see, he knows what fractions are, so that's our baseline. Right? that's the baseline. All right, so if we have two fractions, for instance, 1/2 plus 1/4, we'll draw our little picture here for some of you. And especially because I like drawing pictures.
Do we need to send you back to kindergarten?
Oh, I loved kindergarten. I used to get in trouble in kindergarten all the time, though, and they made me sit underneath a chair. Like that was the penalty. When you got in trouble, you had to go sit underneath the bad boy chair.
Should we have the penalty corner?
Imagine me sitting under that chair now.
The chair would fit over your head.
Just wearing it as a hat. Once upon a time, I fit under a chair.
I like that, and that sounds good.
All right, so that's 1/2.
And recess.
Oh, what time is
Next
recess?
time.
Shut up! We're about to do 3rd grade math for all you pretenders. All right, so we have 1/2 plus 1/4. Here, we'll put our little plus sign in here. Okay, so we're going to add these two fractions together. Okay, so 1/2 plus 1/4. How do we go about adding fractions? What do we need to have first?
Common denominator.
Common denominator. And what's the easiest way for us to get a common denominator?
Using the method that we wrote.
Using the method that we wrote. Did we write the method yet? Did we?
We wrote a method to find the lowest common multiple of a number.
Did we?
Yeah,
I don't know if we wrote it.
I don't think we wrote it yet.
I think
We talked about it.
Okay. Well, whatever.
either in
Whatever.
this class or 320.
So, what's the easiest way to get the what is a common denominator for these two? 8. Well, 4 as a human being, we can look at it and say 4 is the right one, right? But from an easy perspective, could 8 be a common denominator? Absolutely. So we're going to multiply both denominators by each other to get us the new common denominator. That's our 8. What did we need to do to 2 to make it an 8? Multiply it by 4. So we have a 4 here. 4/8. What do we need to do to 4 to make it an 8? So we have 2/8. So is 4/8 the same as 1/2? Is 2/8 the same as 1/4? So our final answer here is 6/8. And that will be what that'll be what we return, 6/8 as an array. Okay, so first thing we need to do, calc the common denom. So int new denom is equal to cat at bucket 1 times dog at bucket 1. The two denominators multiplied by each other.
Instead of denom, we spelled
Demon?
Christian University, sir.
Okay, so
Lutheran University.
these are bad.
Wow.
See, so I just turned it into a Christian worldview. These are bad.
Isn't it at position 2?
Nope.
Oh, no.
2 bucket arrays, bucket 0, bucket 1. So cat at bucket 1 will be the denominator of our first fraction. Dog at bucket 1 will be the denominator of our second fraction. They're 2 bucket arrays. Bucket 0 is the numerator, bucket 1 is the denominator. Okay? So that's going to be our new denom. So in our current example, that is my pictures, new denom would be 8. Okay? But again, to reinforce some of the mistakes I've seen some of you making, that's our current example. This method should work for any 2 fractions I pass it. Make sense? Any 2 fractions. What's up?
Didn't that work for any 2 though?
Yeah, this will.
Oh, yeah.
This will. But some people I've seen, they'll write this all up here like this, and then they'll just put in a 2 times 8 or 2 times 4 down here. Just because they think that's the problem we're solving. You can't do that. It's got to be written generically so that we can use this for multiple fractions, not just for the one example I happen to provide. All right, so that's our new denominator. Now, let's kind of roll this back to our original values. All right, so this is new denom right here. Now, how did we get? We know that to get the new denom, we multiply our denominators by each other. But now we need to get our new numerators. How do we get this numerator? Multiply it by the denominator of the other guy. So car's numerator will now be cat. I did write car a couple minutes ago. So cat's numerator will now be cat's numerator times dog's denominator. Now, do we actually want to change cat's numerator? Only if we want to destroy our original fractions, right? Because these are pointers. So any changes I make to cat and dog here will have permanent changes to F1 and F2 here, because they all point to the same places, right? So what we want to do is we're going to say int new num1 is equal to cat at bucket 0 times dog at bucket 1. Int new num2 is equal to dog at bucket 0 times cat at bucket 1. Make sense? Then we have our new denominator. We know our new numerator is going to be new num1 plus new num2. So we can say int array answer is equal to, actually, will it let us do this? I think it will. And then return answer. So our final answer will be an integer array. It's going to be a 2-bucket array. Bucket 0 will be whatever new num1 plus new num2 is. And bucket 2 will be or bucket 1, which is the second value, will be the new denominator. Did I screw something up?
Mm-hmm.
Did I?
No.
Oh, plus. Plus. These two added together. Okay. And we'll return our answer. Now, we probably want to have the ability to print a fraction, right? So we're going to go ahead and have a static void display fraction. That'll take an integer array f as a parameter, and we'll say system.out.println f at bucket 0 concatenated with a slash concatenated with f at bucket 1. Should look like that's a fraction-like appearance, right? Okay. So just to test that real quick.
Would you just want to print, not print?
It doesn't matter. I mean, this displays a single fraction. I mean, if you wanted to display the whole addition thing, you could certainly make the argument to do print and have it all on one line. Let's just test it for displaying a single fraction. Class method or instance method? Class method. How do you know? Static. How do you call class methods? Which the method is defined. Okay, so we're going to say hw dot display f1, and this should show us our nice 1/2 fraction. If we call display f2, it should show us our 1/4 fraction. If we say display answer, it should show us the sum of those two. That is the result of calling add fractions on f1 and f2. And what should the answer be? 6/8. Make sense? All right. How do we reduce a fraction? Is 6/8 the best we're going to get out of that? So as a human being, we can look at 6/8 and say, oh, we can reduce that. We can reduce this to 3/4. How did we do that? Okay. How did you determine it needed to be a 2? Okay. Just because they're even, does that mean that 2 is going to be the best we can do?
Couldn't keep doing it if it was even.
Okay, so we're looking for correct solutions first, not necessarily optimal ones. So can't we figure out which is the smaller of our two numbers? Because we know we don't need to look at a number bigger than that, right? So we can look at the smaller of 6 or 8. And then we can count down from 6 all the way to 2. Finding the largest value there that evenly divides the 6 and evenly divides the 8. Okay, so we're going to look at our two numbers, 6 and 8. Which one's smaller? 6. So we'll write this code as we're walking it. So we're going to say static void reduce into array f, and we'll actually reduce this guy in place. Okay? So we'll overwrite the contents of f with the reduced version of the fraction rather than return a reduced version of the fraction. That's a decision we're making, but we could certainly do it the other way too. So how do we figure out the smaller value between the numerator and the denominator of f? Huh? Not necessarily. Couldn't we have 15 fourths? That's a legal fraction.
Oh, you just compare bucket one.
So we want to have a storage for smaller, right? And then if the numerator is smaller than the denominator, how do we ask that question? So this says if this fraction's numerator is less than this fraction's denominator, then smaller will equal the numerator, else smaller will equal the denominator. Make sense? So after this line of code, after this chunk of code, smaller will be equal to the smaller of numerator and denominator. So smaller is the absolute biggest value that can possibly evenly divide both values, both the numerator and the denominator. It's the largest that's possible. Not necessarily probable, but the largest that's possible. So for instance, if we had the fraction 6/12, just so happens that 6 does evenly divide 12, but 12 would never evenly divide 6. Make sense? All right. So now we want to keep going down the line. Run this again here. So we're going to find our smallest here. So in this case, 6 is a smaller value. So we're going to ask the question, does 6 evenly divide 6? Yes. Does 6 evenly divide 8? No. Reduce the 6 to a 5. Try again. Does 5 evenly divide 6? Nope. Does 5 evenly divide 8? Nope. Okay. We need to find a situation where smallest evenly divides both of these values. Okay. We know we'll eventually get to 1, correct? Because as soon as smallest gets to 1, we know that 1 will evenly divide 6 and 1 will evenly divide 8. We didn't change them, but we know it'll work, right? It's the rules of math. Math says 1 evenly divides any number. Okay? So, we're going to do something for some amount of time. As long as the current value of smallest does not evenly divide both the numerator and the denominator, as long as that's true, we need to find another value of smaller. Okay, so how do I write that? How do I say as long as, okay, it's a while loop. Why a while loop? Yeah, don't know many times. So while loops lend themselves to looping type problems where we do not necessarily know how many times we're going to have to loop. Now why a while instead of a do while? Are we going to have to do this at least once?
Yeah.
What if smaller is a 1? already set, right? So while, so I want to say here the Boolean expression I want to write is the expression that's equivalent to saying while smaller does not evenly divide both the numerator and denominator. How do we say that?
Wouldn't if I mean,
Don't you have to write a loop that goes down from?
Well, we're in the middle of a loop right here. But loops require Boolean expressions. So I need a Boolean expression right here. What's a Boolean expression?
anything that goes down to a single value.
Any expression that boils down to a single value of true or false. So I need the Boolean expression that's equivalent to saying while smaller does not evenly divide the numerator and the denominator. Go ahead.
So a smaller mod in the position of numerator is not equal to 0.
Smaller mod. What's the position of the numerator?
0.
Just 0 like that?
No, the F
F at 0.
and then smaller mod 1. Is not equal to 0.
Okay, and you wanted to say did not equal to 0 over here too, right?
Yeah.
Okay, just like that. Somebody help him fix it. It's close. In our example, 6/8, smaller would be 6. Are we interested in whether smaller mod 6 is equal to 0? Or are we interested in whether 6 mod smaller is equal to 0? Flip it to the other side when we deal with the 8s. So we have smaller is going to be 6 in our 6/8 example, right? Okay, so when we say 6 mod 6, that's true. We're not sure which 6 is which, right? Let's go to the other side. Are we interested in 6 mod 8 or are we interested in 8 mod 6? We're interested in the 8 mod 6. Does 6 evenly divide into 8? Okay, so these guys should just be reversed. So F at bucket 0, mod smaller is not equal to 0. And F at bucket 1, mod smaller is not equal to 0. So this statement will be true, which says we should keep looping. So as long as that Boolean expression boils down to true, we will keep looping. This will only be true when what's true? When both of them are not evenly divisible. We're interested in whether either of them is not evenly divisible. Because of the example of 6/8, is 6 evenly divisible by 6? Yes, that's a true. Is 8 evenly divisible by 6? That's a false. True and false is what?
False.
False. Loop's done. We think we have our smallest common denominator, but we don't. So right there, we would try to divide 6 and 8 by 6 and get a bad result. We need this to keep spinning because both of them are not evenly divisible by it. So this Boolean expression says, if we correctly write it, this Boolean expression says, if either the numerator or the denominator is not evenly divisible by smaller, if either of them breaks the rule, let's try again. And what does it mean to try again? Smaller minus minus. Try the next value down. 6 didn't work, let's try a 5. 5 didn't work, let's try a 4. 4 didn't work, let's try a 3. 3 didn't work, let's try a 2. Ah! Is 6 evenly divisible by 2? Yes. Is 8 evenly divisible by 2? Yes. So 6 mod 2 not equal to 0? Is that a true statement? No, it is equal to 0. So that's a false statement. 8 mod 2 not equal to 0? That is equal to 0. That's a false statement. False is what? False. So now we'll move past the while. Smaller is now equal to the largest value that evenly divides both the numerator and, I'll kick it down. And the denominator. Make sense? Okay. So now we actually need to do the we need to reduce. How do we reduce?
Numerator and then, or the other way around. Numerator divided by small.
So it's f of 0.
F at bucket 0, which is our numerator, divided by smaller, is going to give us what?
The new, we create a new numerator.
Do we need to create a new numerator?
Oh, no,
Yeah, we're doing this in line, right? So F at bucket 0, so overwrite the current numerator with itself divided by smaller. Overwrite the current denominator with itself divided by smaller. Now we're done. Let's reduce. So there's answer. And then we can say, well, then we can say HW dot reduce answer, and then display it again. And we should get the reduced version of answer. Make sense? All right, so questions about that? What else might we want to do with fractions? Divide fractions? How do you divide fractions?
multiplied by the
Oh, multiplied by the reciprocal. Okay. Static int array divide fractions. Int array cat, int array dog. By the way, I would not encourage you to use variable names like this. I'm just trying to reinforce the fact that these variable names don't have to match these variable names. Okay? So you get a slide for this one assignment. Okay? Okay? I do want you to use variable names that make sense. Huh? Okay, I do want you to use variable names that make sense because having good variable names is a very important part of writing readable code, so that somebody else can come and look at your code later on. You know, something you hear in industry is you want to have what's called self-documenting code. I tend to write comments in here for us so that we know what the state of stuff is after certain parts of the code. Now, having said that, I think the comments that I have in here are very appropriate. If you were writing this professionally in industry, even though we have variable names that seem to make sense inside here, having a little comment after that if else gives us some information. Having another comment after that while loop gives us some more information. That kind of gives us the commentary of, hey, what just occurred up here? What's the current state of the world after that while loop? I think that's reasonable comments that you should start working on putting into your code. If nothing else at this point for you, it'll help you consider what little mini task of the bigger problem did you just finish accomplishing. Make sense? So that's kind of what we've been doing. When you draw the picture and you come back here and do it, and you kind of do it one step at a time, go ahead and put a little comment in there that says, here's the mini task I just did. At this point, this value will be this guy. Okay? But as a general rule, you want to write code that is as self-documenting as possible. Okay? remember way back when I first took some of my programming classes in college. I had been programming for a long time before that, and my teachers always annoyed me because they would have like number of comment requirements for the homework. Like you must have 15 comments or more, as part of it was almost like the length of a paper. Or they wanted us to comment after each variable what that variable's for. That's like a reason to use poor variable names. I had another teacher for a C programming class that he was a weirdo. Seriously, he was talking like, oh yeah, great programmers like me, we like to use Gothic variable names or something like that. Just okay. I may have thought that was stupid because of my age. Okay. So we might want to, wasn't I getting ready? Okay. We might want to divide fractions. Should return the result of cat divided by dog. That's what this guy should do. What else might we want to do with fractions? Multiply.
Well, could we just change so come up with multiply first, and then flip flop just the two of dog and the divide, and then call multiply?
I would think that would be a very reasonable thing to do. Very reasonable thing to do. Should return the result of cat multiplied by dog. Okay, so we need to be able to divide fractions. We need to be able to multiply fractions. Make sense? Anything else we think we want to be able to do to fractions?
You just subtract.
We don't need to subtract?
No.
Why not?
It's not necessary. It's not.
Subtract fractions.
It's funny because the bottom one changes already to add fractions.
Minus dog. All right, so you should add these 3 new methods to our code. I gave you the headers for them. You just need to fill in the blanks. Okay? So how does subtract fractions work?
It's the exact same as add, but you switch to subtract.
Exact same as add, except subtract. Okay? Shouldn't be rocket science. Make sense? Questions, comments, concerns, bribes? So I'll put this code up as a starting point for you. And this is due on Tuesday. And if you do a good job on this, and you pass the quiz that I'm likely to give you on Tuesday, I may not give you homework over Thanksgiving break.
I'd be happy.
There's several ifs in there, though. All right? Because I get to eat turkey whether you have homework or not.
Wait, is it the individual
do
basis
you
or
get
is it
to
a
eat
class?
turkey?
No, as a class. If I'm disappointed in you as a class because of poor performance, you get homework.
Do we get to decide if we have homework or not?
I actually don't care what you do.
You don't care what we do.
All I'm saying is I control whether or not you have homework.
But you
I
gotta
can't
think
even
about-
control whether or not you do it.
If you assign us the homework, you got to think about grading it while you're eating that turkey. If you assign
No,
us
because it won't be
homework,
due
then
till
you might
afterwards.
not be thankful.
See, that would be
But you still have
a
to grade
jerk
all the
move
other
if I gave you homework and made it due on Thursday. Give you homework on Tuesday, make it due on Thursday. Look, I don't make the rules.
It's due on Thanksgiving.
It's due on Thanksgiving, people. So that means study, be ready for a quiz, and do a good job in your homework, and avoid an assignment.
What might possibly be on this quiz?
I don't know. It depends what I feel like that day.